All right, good day everyone. My name is Epaphras, and in this section of the class, I'm going to be taking you guys on vertical motion. Okay. Now, the first thing I have to know is when I see or hear of the word vertical motion, something that should come to my mind is the motion that is completely under the influence of gravity. Okay. So, in vertical motion, we could have bodies that are projected vertically upwards. Okay, and returns to the ground, or bodies that are falling freely, okay, from a height to the ground. Okay, we could have throwing the body vertically upwards, and the body misses the point of projection and falls on the ground. Okay, we could have bodies that are projected from a height to another height. Okay, or from a height higher to a height lower. Okay, what I'm trying to say is you could have bodies projected like this from a height to another height that is higher, or from a height that is higher to another height that is lower. Okay, we're going to do those cases and we're going to treat everything again. Now, the first thing I'm going to do is we should remember that when a body is projected from a point, from a position, let's say this is a body, and the body is projected vertically upwards. Okay, now when the body is projected vertically upward, it is rising against gravity. So our value for acceleration to gravity is going to carry a negative. Now, but when the body is falling, okay, when the body is falling from a height, okay, it is falling with gravity. So we're going to be using positive acceleration to gravity. Now remember that the time where two bodies of different masses, okay, drop from a height, the time that they're going to land on the ground is going to be the same time, okay. Now, because the rate of acceleration for both bodies is the same. Okay, the rate of acceleration is moving is the same. So if I have a mass of 50 kg and another mass of 10 kg, okay, that are dropped from a height, neglecting air resistance, neglecting air drag or air resistance, both bodies are going to land at the same time. So it means that if I pick a stone and I pick a feather, okay, a feather of large area. Now, if I decide to remove air from a particular environment and drop those two bodies, the feather and the stone, both bodies will land at the same time because both bodies have the same rate of acceleration, which is acceleration to gravity. And remember, acceleration to gravity has a value. It is 10 meters per second square, or you could say it is 9.8 meters per second square. Okay. Now, the 9.8 meter per second square is the most correct value for acceleration to gravity. Okay, the 10 meter per second squared is just an approximated value. All right. Now, back to what we're doing. Again, back to what we're doing. We have to remember the equations of motion to use in this aspect. Okay. Now we're going to use all our equations of motion. But what are these equations of motion? Again, the first one we'll talk about is that V is equal to U plus or minus GT. Okay. Yes, U plus or minus GT. This is the first one. Okay. Now the second one we're going to be talking about here is V squared is equal to U squared plus or minus 2GH minus H naught. Okay. Now this H minus H naught is actually change in the position of the body, which is final position minus initial position. Now what H here stands for? H stands for final position. H stands for final position, while H naught stands for initial position. Okay, now remember this is the best way to write your equations of motion, the best way to write it. Now, the third equation of motion, equation of vertical motion I'll be showing to you now is change in H is equal to UT plus or minus 1 over 2 GT squared. Okay, yes. Yes, now these are the three equations of motion that we are going to mostly work with when we talk about vertical projections. Okay, now remember we can redefine this to be H minus H naught is equal to UT plus or minus 1 over 2 gt squared. Okay. Now, when do I use a positive and when do I use a negative? Now, I'm going to use a positive if the body is falling with gravity. Okay, I'll use a positive sign. But I'm going to use a negative if the body is rising against gravity. So when you hear that the body is projected vertically upwards, just know that you're going to be using negative g. Okay, so in this equation here, we're going to be using, if I should write them again, I'm going to have a section v is equal to u plus gt. Okay, v squared is equal to u squared plus 2gh minus h naught. Okay, h minus h naught is equal to ut plus half gt squared. Okay, now I will use these guys when the body is falling with gravity. When the body falls with gravity, okay, falls with gravity. Okay, we use positive. Then the equation becomes v is equal to u minus gt. Okay, v squared is equal to u squared minus 2g change in h. Then change in h is equal to ut minus 1 over 2 gt squared. Okay, now I'm going to use these guys when the body is rising against gravity. So for bodies that are rising against gravity, you use this guy. Okay, but when bodies that are falling with gravity, we use this guy. Okay, now remember that every question under vertical motion, okay, will involve that you look for one of these parameters. Here we have about 5 parameters here. We have v, which is we have 5 parameters here. We have the v, okay, we have v, we have u, we have s, okay, or you know we have h, we have h naught, we have t, okay, we have g, okay, which is 1, 2, 3, 4, 5, 6, okay. So there are 6 parameters here. Remember that v stands for final velocity, u stands for initial velocity of projection. We have h is the final position, then h naught is the initial position, t is the time, and g is the acceleration due to gravity. Okay. Now, after learning all these formulas, after learning all these equations, it means that normally you should have these equations in your head at any point in time because you will be needed to apply any of them or both. Now, there are some questions that involve that you apply both equations to solve a question, or just some questions that we just need to apply just one of them and you get the answer correct. Okay. So after this step, now we're going to be treating different cases. Okay, we're going to be treating different cases for vertical projections. Now, what are these different cases? I'm going to show them to you now. The first case we're going to treat right now is a body that is projected vertically upwards from a point and returns to the thrower. Okay, a body that is projected vertically upwards from a point and returns to the thrower. So this is what we have here. We have the point, this is the point of projection. The body is projected from here, okay, vertically upwards and returns. Okay, the body is projected and returns. All right. Now, so what should I understand for this kind of projection? And what are the kind of questions that will be asked? And remember that the body is projected with an initial velocity u. Okay, this u is actually a maximum speed. All right. Now, when the body lands, remember that it's going to land with the same u and its maximum. So it means when the body is projected from a point and moves vertically upwards and comes downwards, okay, coming to the point of projection. Remember, it lands at the same point of projection. That body is going to be projected with a speed and land with the same speed. Now, the body is going to get to a height. Okay, this height is what we call the maximum height. So, from this highest point where the body reached to the ground is called maximum height. Okay, so it's the highest vertical projection that is vertical position that is reached by the body. Okay, now you're going to be asked what is the maximum height reached by the body. Now you're going to be asked what is the time to reach maximum. That's to say The time from the point of projection till the maximum height is called time to reach maximum height. Okay. Now, if we call it small letter t, okay, we call it small letter t, it takes the same time to rise and to fall. So it means that if it takes t to move from here to this point, it will also take the same t, it will take the same t to move from here to this point. Take note. So it means that from here to here is time to reach maximum height, but from here to here is also time to reach maximum height. Remember. So now, remember also that at the highest vertical position, the speed is zero. Okay, but remember, the speed here is Vy. Okay, the vertical speed is zero meter per second. So it means that when the body is projected vertically upwards, now it gets to the point where the body stops and the body returns. Okay. Now, at the point the body stops, the final speed is zero. So the body is rising, the speed is reducing, and when it gets to the highest vertical position, okay, the body stops, okay, and the body starts coming down again, and the speed starts rising again. When the speed hits here, the speed is maximum. So it rises with the highest speed and lands with the same speed. Okay. So how do we obtain the time to reach maximum height? Okay. How do we obtain time to reach maximum height? How do we obtain time to reach maximum height? It's very easy. Now, remember that at maximum height, V is zero. So recall, I gave you a formula. Recall, I gave you that V is equal to U minus GT. I gave you this formula. And I've told you already that maximum height V is zero. So it means that we can say zero is equal to U minus GT. So let's make T solid from here. If I take T to the other side, what we're having that GT is equal to U. If I decide to find T, divide both sides by G, divide both sides by G, my T therefore becomes U over G. So we have the first formula, and this first formula tells us that the time to reach maximum height for a body that is projected vertically upwards and returns to the shoulder is what now? U over G. Remember, U is called initial velocity. Now again, how about the time of flight? How about the time of flight? Time of flight. Remember I told you already that the time of flight is the time to move from the point of projection, okay, down to the point the body lands again. Okay. Now remember I told you already, there are two ways to get the analysis for this. There are two ways. I can decide to do this. I can say, okay, I could use H minus H naught is equal to UT minus 1 over 2 GT squared. Now watch me. You can see that the body started from a point where on the ground where H is zero and lands where H is zero. So final initial position is zero. Final position is also what now? Zero. So I can say that 0 minus 0 is equal to UT minus 1 over 2 GT squared. Okay. Now this means that 0 is equal to UT minus 1 over 2 GT squared. Okay. Now we want to make t subject. So what we have here, we have half GT squared is equal to UT. Okay. Now one t will strike one t here. So what we have is half GT is equal to U. So if I make T subject, T is going to be 2U over G. Okay. Now if we use this analysis to get the time of flight, that is the time to move from here down to this point, you could also do this. You could say, remember we said that time of flight is from here to here, which is small letter t, plus from here to here, okay, which is also small letter t. You could say this. Then, so your time of flight becomes about 2t. Remember we've said already that our small letter t, which is time to reach maximum height. Remember we said it's u over g already. So we have u over g. So t becomes 2u over g. Okay. So if the question asks you, what is the time to reach maximum height? This is the time to reach maximum height, u over g. The question asks you, what is the time of flight? I use two methods. This is method one and this is method two. Okay. In method one, I use this formula. Change in h is equal to what? Change in h is equal to ut minus half squared. Okay. I use this method and I got the time of flight. And I told you you could also use this shorter method here. You will get the time of flight. Okay. So what we have here is uh, the time to reach maximum height, and We also have the time of flight solved here. And the next analysis we're going to be doing now is how to obtain the maximum height that is reached by the body. Okay, the maximum height that is reached by the body. Okay, so how do we obtain the maximum height reached by the body? We could use this equation of motion. We could use v squared is equal to u squared minus 2g into h minus h naught. Okay. Now remember at maximum height we said that v is equal to zero. Okay, so v is equal to 0 meters per second at maximum height. And also we can now rephrase the equation. Remember it's moving from where h is zero, initial height is zero. So it means moving from where h naught is equal to zero to maximum height, that is where h is equal to h max. Alright. So it means that we could say that 0 squared is equal to u squared minus 2g into h is the final height. Final height is the maximum height. Okay, that's h maximum. And the initial height is 0. Alright, so what we have here becomes we have 0 is equal to 0 is equal to u squared minus 2gh maximum. Okay, so at this point now let's collect items. By bringing this to the other side here, we have 2gh maximum is equal to u squared. Okay, so you can also say this. You can say that we divide both sides by 2g, divide here by 2g, then 2g strikes 2g. We now have that h maximum is equal to u squared over 2g. So if we are asked, okay, if we are asked for the maximum height reached by a body that is projected from a point and returns to that point, the formula is u squared over 2g. We know what u stands for, initial velocity, and the g stands for gravity. All right. Okay, now at this point in time, we've learned how to find the time to reach maximum height, the time of flight. We've also learned how to find the maximum height reached. Now the last thing I'll tell you, if they ask, what is the speed of landing? Remember that is the initial velocity of projection is the velocity of landing. For a body that is thrown upwards and returns to the ground, okay, the initial speed of throw is the initial speed of landing. Take notes, okay? Take notes. All right. So at this point, we are moving straight up to the next analysis. Okay, we're moving straight up to the next analysis. That would be projection, projection from the ground to a height. Okay, projection from the ground to a height. There are questions that will go like this. Okay, to tell you that a body is projected. Okay, a body is projected from the ground. Okay, to a height. Okay, it's projected from the ground to a height. Okay, and they're asking you what is the speed of the body at this height. Okay, that's what it's saying. Body, look at the body. Body is projected. Okay, body is projected from the ground. Okay, to this point. Okay, and you're asking us what is the speed of the body at this point when the body is h meters above the ground. When the body is h meters above the ground, now it's still very very easy to calculate. How do I get the speed at this point? Okay, how do I get the speed at this point? So remember that at this point now h initial is 0, then h final is h. Okay, so I could look for the time of flight. I could look for the time of flight. Yes. How do I get the time of flight? How do I get the time for the body to move from here to here? We could use h minus h naught is equal to ut, okay, minus 1 over 2 dt squared. Okay. Now in this case now h naught is 0, so we're having h minus 0 is equal to ut minus 1 over 2 dt squared. Okay. So If we rearrange this equation now, what we're going to be having h is equal to ut minus 1 over 2 gt squared. Okay. Now let's clear out all the fractions that we have. We multiply by the LCM. Okay. So we're having 2h is equal to 2ut minus gt squared. Okay. So carrying everything here to the other side, we'll be having gt squared. Okay. Minus 2ut. Okay. Plus 2h is equal to 0. Okay. Is equal to 0. Now with this formula, I could find the time of flight. Okay, I could find the time of flight for the motion of this particle. But what is the formula to look for general time of flight? Formula to look for general time of flight. I would just like not really make the analysis of putting h not as 0 and h as h here. What I will just do is I will just work with this. I will say h minus h naught is equal to ut minus 1 over 2 gt squared. Okay, clearing fractions, I'll be having 2 into h minus h naught is equal to ut minus gt squared. Okay, rearranging, so I'll be having gt squared minus, there'll be a 2 here. If I clear fractions, there'll be a 2 here. Minus 2 ut plus 2 into h minus h naught equal to 0. Okay. Now this formula is the formula for the general time of flight, gt squared minus 2ut plus 2 into h minus h. Remember that the h here is the final position, okay, and h naught here is the initial position. Now it works like magic. This formula can look for vertical projection any time of flight. Just remember the point it was projected from h naught and the point it was projected to h. Okay, just remember that and you'll be good to go. Okay. So this formula I can look for initial velocity, I could look for time, and I could also look for height. Okay. Now I want to now look for the formula. What formula? I want to get the speed of the body at this point. I want to get the speed of the body at this particular point. What do I do here? To get the speed of the body at that point, we could do this. To do this, okay, we could use this formula. V squared is equal to u squared minus 2g into h minus h naught. We could use this formula. With this formula, I could get what now? I could get the speed, the final velocity. Well, let's work with this. Look at the board. Let's work with this now. Remember that h naught is 0, so we're having v squared is equal to u squared minus 2g into h minus 0. So this is what we'll have here. We'll be having v squared is equal to u squared minus 2gh. Okay, yes. So to find v becomes the square root of u squared minus 2gh. So this formula becomes the formula for the final velocity at a particular height when a body is thrown from the ground. So when a body is thrown from the ground, you're asked to look for the final velocity at a particular height. You could use this formula. Okay, just use this one. Okay, use this formula here. Just remember, if you're using this, your h is the final position, your h naught is the initial position. Okay.